The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone, and welcome to the first in our 2019 webinar series, which is BIM for product manufacturers. It's a lovely day outside today. The sun is shining. It's a little bit chilly, but thank you for taking some time out of your busy schedules to join us this morning. I expect this session will take somewhere between 45 minutes and an hour. We'll start off with a little bit of PowerPoint, just introducing building information modeling and digital construction, why it exists, start talking about it very specifically from a manufacturer's point of view. And then towards the end of the session, we'll show some technology where we have different ways to create, let's say, BIM compliant models for more of a better world from the likes of Autodesk Inventor. You are all on mute mode, so you don't have to worry about sitting there in silence. You have a bar on the right-hand side of your screen where you can ask questions. Please feel free to ask questions throughout the session. I'll be focused on delivery myself, but I have some colleagues that are sat there looking for the questions to come through. But hopefully you should hear me nice and clearly. Hopefully you'll be able to see my screen. And without further ado, we will get started. So as I say, I wanted to start today with a bit of a presentation, just to kind of introduce Man & Machine as an organization, as well as introducing digital construction and BIM. So firstly, a little bit about myself. My name's Robin. I'm the technical manager here at Man & Machine. I've been here for just over 15 years, doing pretty much all things to do with technology, both in the manufacturing space and in the construction space. So you could say I'm pretty much a self-confessed geek who likes everything to do with technology. I come at BIM from that point of view, so from a technology point of view, trying to link systems together, interrogate data, and make sure that we're using the best of the technology to get the right outputs in a timely fashion. And a little bit about the company. I'm guessing most of you know us. We are the biggest platinum partner across Europe for Autodesk. We became a reseller after being a distributor for many years in 2009, and we have advanced specializations across the board on the Autodesk side of things, with over 750 staff members and over 150 engineers across Europe in several different locations. If we just take a little look at the type of software that we offer, I guess first and foremost, yes, we are an Autodesk house. So whether it is on the manufacturing side or the construction side, we have the breadth of the latest and greatest technology from the Autodesk team, of which it's fantastic from a digital construction perspective. But alongside that, we also have our own offerings. So we offer our own software that ties into the likes of Inventor with Custom X, ties into the likes of Vault with PDM Pinpoint, and also ties into the construction market with Revit with the likes of BIM Booster and Map Edit. But we've also understood that to be compliant in these industries, sometimes you have to branch out and make sure that you've got a piece of software or a piece of technology that leverages the technology that you already have. So for example, any Revit users out there that really want to drive high-end rendering, you have the likes of Enscape, for people that want to issue and manage tracking of clashes and problems between the likes of Navisworks and Revit. You have software like BIMtrack. We have partnered with all of these different software vendors and partners with these different standardization committees such as Building Smart, the UK BIM Alliance, CPD and BSI, to make sure that we are offering our customers the latest and greatest technology at the industry leading standards and specializations as well. So a little bit onto our training services before we jump into the actual webinar. So we have a BIM Ready program, and actually what you're about to see today, a lot of the slides and the content come from some of that BIM Ready program. So I just thought it'd be interesting just to start by explaining that we have these tiered approaches when it comes to our digital construction training offerings under our BIM Ready program. And they start from everything from a BIM modeling perspective. So if you want to learn how to create families natively inside of Revit, we have a training course to do so. If you want to learn how to coordinate or manage a BIM project or deliver against a BIM project as a construction professional, we have a course to do that. And each one of these courses is layered so that they cover 3D BIM and digital construction alongside coordination, processing QA, and the management side of things and the deliverable side of things as well. Now, those set of courses have been running for a number of years now, are very well developed. We receive fantastic feedback, And because of that, we've actually taken that breadth of knowledge and information and released a new course this year, which is BIM for product manufacturers. And that course is essentially built on the bones of the BIM Ready program. So we've got a lot of industry professionals that have built these courses for us that work for Man and Machine from industry, and we've taken those guys from the construction industry as well as our engineers from the manufacturing industry and put them together and come up with this course that's specifically looking at delivering BIM objects and driving BIM standards for a product manufacturer. And again, some of the slides that we go through this morning are from that course set. So it's a very exciting course. We've already had a number of runnings of this and had a lot of feedback, which we're really pleased with. So by all means, if anyone has any queries or questions about that course, please get in touch. So with all those bits out of the way, I've put together a rough agenda, let's say, and these are just points that I just want to talk about throughout the training or throughout this session this morning. And I think, firstly, it's really important to just discuss a little bit about building information modeling or digital construction, however you want terminology. And we look at this in this very specific way. So when you look at BIM or digital construction, we focus that there are 4 key areas to the adoption of that, whether you are a manufacturer and you're thriving to develop BIM object standards, or whether you are someone that's in the construction industry. We recognize that there are people that you need to be able to structure in your organization and train so that they can deliver against your requirements. There are guidelines that you have to follow, whether it's the ISO 19650 parts 1 and 2, whether it's BS 8541, which we'll talk about a little bit later. And then we have technology to deliver those things through hardware and software, as well as processes to support the management of those things. And what we recognize and try and push through all of our courses is that actually there's a very good reason on this diagram why people and process are the biggest parts of the chain, because they can be the most difficult people to change and the most difficult people to align. Guidelines are very easy to follow. You can download them from the internet and read them. Straightforward, no issues at all. Technology. Pretty much anyone that's been in this industry for a while can pick up a piece of technology, whether it's hardware, a VR set, software, the latest release of Inventor with BIM Exchange. We have the ability to learn those tool sets very quickly, either on our own or through professional training. It's always changing people and changing processes within an organization that is the most difficult. And our entire course is built around that premise and that workflow. So if we just discuss BIM for a second, building information modeling. People try and not talk about the word BIM nowadays and call it digital construction. But essentially, there's nothing new here. We've been doing this for a long time, but it's trying to modernize the construction industry so that we have a building information model or a virtual version of the building, if you like. And that virtual model is used for everything from creating drawings to doing model coordination to doing simulations or analysis. We're manufacturers, right? So we are very used to digital prototyping and the fact that we have a digital model and we use that digital model in Inventor or in SolidWorks or whatever else it might be for everything. All of our drawings come from that model. Our simulation and FEA come from that model. We're trying to do the same thing in the BIM world, and whilst we've been using the likes of Revit, Tekla, ArchiCAD, whatever else it might be for a very long time, we're just trying to modernize the construction methods that we're using and the way in which we're collaborating and working. The first thing to really point out is that this is not technology. So BIM is not Revit. Revit is a fantastic BIM authoring tool, absolutely. But you're not BIM compliant just by having a Revit model or just by leveraging Revit inside of your building or inside of your business. Building information modeling is a process. And actually what it tries to drive is better information management, better sharing of data, better communication of data, and better collaboration on a project. Better put, it's really trying to bring the construction industry into a modern world. You know, if you look at the evolution of communication, we've gone from doing cave paintings all the way to using WhatsApp, Facebook, Instagram, Twitter, whatever else it might be. And whilst, yes, they're very far-fetched examples, what we're trying to do is make sure that we don't send digital designs on an email, for example. When you're communicating with people in your personal life, how often do you send them an email? Well, the answer is you don't. You ping them a WhatsApp, or you ping them a Facebook message, or a Skype call, or something like that. We have common data environments in the BIM world that allow us to control the communication of our designs, to make sure that they're structured, to make sure that they're intelligent. And the key here is just making sure that we're following this natural technology evolution. These next slides, if anyone's ever seen any digital prototyping workflows from Autodesk or similar, these will look very similar, apart from this first one. So what we're trying to do with building information modeling is get away from this traditional process of having huge expense during construction. The reason we have huge expense during construction is typically because we get to site and we find problems. Now, what BIM tries to do is find those issues earlier on by getting models produced earlier, getting models coordinated with different disciplines earlier, so that you can find clashes between ductwork and steel, between architecture and an MEP earlier on in technology rather than when you get to site. Whilst that doesn't necessarily mean that much to you manufacturers on the call, what it does mean is that having your models accurately virtualized for use in a BIM process is key. Because if you've got a boiler, for example, and that boiler has a specific access area that it needs to be able to get to and service and access that boiler, that needs to be known and that needs to be understood. Otherwise, it could be that someone without the right know-how places that component in a model without the relevant access, whether it's access or ventilation space. It's key that we get our intelligence as manufacturers into our models so that they can be used. Essentially, the possibility of controlling the costs goes down the further along the project we are. And obviously the cost of those changes goes up because we've got to send back materials, we've got to fix things whilst on site. Whereas if we find the problems earlier, we can fix them very easily using technology, using designers on a piece of software. So it's really just trying to do something that actually in the manufacturing space we've been doing for a very long time with digital prototyping. We don't want to have these drop-offs in information, in coordination, when we hand over between phases. The same goes in a BIM workflow for construction. Using this methodology and these processes, it gives us a much smoother process throughout the process, or throughout the timeline, from concept design, from preliminary project, all the way through to when that asset is being operated. Okay, fine. So why? Why would I go around and change this process? Yes, it sounds relatively straightforward so far, but let's kind of really put that into context. We have these 3D models, and actually what's happening at the moment is those models are printed onto a piece of paper, and then that's used for coordination, collaboration, design review meetings, and redline markup. All of this model is saved in the cloud, so why are we going through and running through this very manual process? Believe it or not, we then create PDFs which are then printed to run through the same process. Those PDFs are sent to individual organizations to use on site, for example. We have a load of information in the model, so why are we going through this headache of having tons and tons of paper? I know there's one individual within my organization that really hates paper and really wants to drive the push for digital collaboration using technology, which is great. I think he's watching now, so he'll be really pleased about that. But why are we running through this process? It's a big headache, and actually it's really painful to manage. Think about when a building's handed over at the end. You've got this massive number of O&M, operation maintenance manuals and management manuals. It's such a big pain to handle that process. Whereas we have a digital model, we have an intelligent parametric model. We can use technology to redline markup. We can use technology to view and pinpoint issues on a mobile device on the site, or on a mobile device in front of colleagues, to be able to collaborate on technology as we're going through the process, so that all of the information and all the data is held centrally in a managed, controlled environment. That's really where we're trying to get to. Fine, okay, but how do we get there? Well, one huge problem in the industry is people think about digital construction, they think about BIM, and they see an iceberg. So what they actually see is 3D visualization using, for example, Revit, coordination designs using, for example, Navisworks, and pulling some basic quantity information from that model. So they're kind of blinded by the software, the hardware, and the training involved to use those software and hardwares. And actually, the biggest challenge or the biggest adoption actually happens underneath the surface, because what you have underneath the surface is a load of deliverables and a load of very specific requirements. Deliverables would be known as a BIM use case. In other words, using that building information model, that virtual building, to deliver stuff. That stuff is going to be a requirement, such as delivering against a given workflow or delivering against a certain collaboration piece. We have a load of BIM deliverables and a load of standards and requirements that we must follow to live within this world. And I think just sometimes we're blinded too much by the fact that, yes, we've got some great technology. It's cool. I love it. I use it every single day. But that is the very tip of the iceberg here. There's a lot more going on underneath. And I hope to really bring some of that to life in this session today, because you really won't see any value until you get all of that and put it together. That's when the value comes at the end, when you've gone through the modeling process, you've gone through the construction, you've gone through the handover, and you're using and operating the asset. As manufacturers, we're involved in a very small piece of that, but our asset is being used day to day inside a facility at the end of this. And the value for a BIM project is only seen when you put and tie all of that information together. So let's give you some examples of that. We have a BIM model here, a building information model. And that model, as I've said, is used for a number of use cases. Those use cases, as I say, for more of a better world, are using the model to do something to your benefit. So that could be as simple as I've got the model and I'm using it to automatically generate my sheets and my drawings. That could be I'm using the model and I'm sticking a VR headset on so I can go and have a look around. We've seen manufacturers that they work with structure, and they're actually embedding information and intelligence into that structure so that you can run conduit and cable down the structure without having to have separate boxes, so on and so forth. And they can actually visualize that and view that in VR because they have a good quality of model. Let's just look at another couple of examples. One that's really key for manufacturers is digital fabrication. So actually, when we work inside of the likes of Revit, if we draw standard ductwork, we just get a very representative object, which is fine for what we need to do. But actually, in reality, the sheet metal manufacturer puts flanges on there. They have different radiuses that they have to work with, and the result is very, very different. Nowadays, inside of Revit, we have the ability to convert these very representative shapes into fully detailed and intelligent parametric fabrication toolsets or fabrication components directly inside of Revit. Any manufacturers on the call that are using CAD map or fabrication products from Autodesk, these tie directly into Revit. You can supply your databases to Revit users so that they can actually design their ductwork, design their routes and their runs with your fabrication parts, meaning that this process can actually flow end to end from a very first concept design through to a detailed design through to a fabricator without as much difficulty as it does at the moment. Let's take another one. So let's go ahead here and not quite sure what's happened there with my animation. Apologies for that. That's a chair keyboard interface issue, i.e. me. Let's look at clash detection. So if we take clash detection, this is probably the biggest BIM use case that you'll have heard of. So clash detection inside of a piece of software like Revit, like Navisworks, like Solibri, like BIMtrack, whatever it might be, gives you the ability to clash multiple components in multiple models together. Fine. If you're a structural engineer and you're an MEP designer, you have the ability to make sure that your ducts don't clash with your steel. Perfect. We can report on those inside of several different pieces of software. Perfect. But what does that mean for a manufacturer? Again, imagine that you've got a very intelligent model that has all of the information about the access, the free space that's required, the space that's required to actually get a component into its resting location. If we can put all of that information into an object, it means that when it's clash detected, everything starts to come to life, everything starts to make sense, and actually you get a very intelligent clash detection output at the end of it. Probably the biggest part of BIM and the biggest part of this process is the change in the amount of information that we are driving against the model. And actually, as manufacturers, you guys have got a key part to play in this, because there is a number of bits of data, parameters, properties, metadata, whatever you want to call it, that we need to push into a BIM object or into a BIM model. Because it's key that we know what an object is, why it exists, what flow a certain pump has, what amount of air an air handling unit can push through a duct. And in some cases, or in a lot of cases, it's only us as manufacturers that have the ability to drive this from the bottom up or from the top down. So that when the architect is placing the components in their model, when the structural engineer or the MEP designer is placing those components in the model, they have a good level of data that is intelligent and actually gives them some meaningful results and outputs from the offset, so that they're not ordering the wrong equipment from you, or they're not getting to site and finding out that something is underspecified. Because what BIM does really, to use a made-up word, is it Googleizes a project. So what you have is a hierarchical structure against a load of metadata or properties. So that hierarchical structure gives you the ability to focus on, okay, what's a parent? What child do we have under that parent? We have these relationships where if we look at a Revit model, I can click on a piece of furniture that a furniture manufacturer has created an object for to place in a Revit model. And that piece of furniture will know that it's sat on a floor, in a room, in a space that is used by people. So you can start pulling off room data sheets, you can start to get COBie information directly from the object. Everything in BIM, in the BIM world, whether it's the model, whether it's the classification systems, whether it's the handover formats, is hierarchical. And it's like that for a reason, because it becomes very easy to decipher and to work through. And then against that hierarchy, we've got loads of properties. In my mind, probably too many, if I'm going to be completely honest with everyone on the call. But we have a load of metadata. That metadata is controlled by a number of different standards that we'll talk about shortly. But essentially, with the metadata alongside the hierarchy, we can instantly see every single component that we need to be able to see at any given point in time with the information that is important. And again, a lot of that data is stuff that the people that are placing these inside of Revit models just won't know. And the only people that will know it are the manufacturers such as yourselves. Standards have a huge part to play in all of this. And the standards that we use in the BIM world are not few and far between. There are a lot of them. I'm not going to talk about every single one of them in detail today because, quite frankly, from a manufacturing perspective, you just don't need to know about them. There are some that you definitely need to read and understand if you want to provide BIM objects, if you want to be able to drive BIM adoption from as a manufacturer back to the people that you are working with and collaborating with. And that's namely things like BS 8541. We'll talk about those shortly. But typically, we've got lots of standards from the way a file is named, from the way that a file is managed, to library objects, to handover standard formats. And these are all underneath the surface. They're away from the tip of the iceberg. These are those things that are sometimes unseen and unappreciated. These are really what's key to make sure that we are adopting and driving this BIM process. I thought I'd put a couple of additional slides in here. Just for anyone that does get involved with design build. So if there are any manufacturers on there that are actively working on projects, we now have ISO 19650 launched in the UK, which replaces PAS 1192 parts 1 and parts 2. Okay, so we used to have BS 1192 for naming and PAS 1192 part 2 for project delivery. We now have these two BSEN ISOs, which basically take over those standards. If you're working on projects at the moment, there will be no change. If you're using PAS 1192 Part 2, you will continue to use PAS 1192 Part 2. But if you get taken on a new project, the likelihood is you will now have to follow 19650 Parts 1 and Parts 2, which covers the concepts and principles of a BIM model, as well as project delivery standards and the naming, which is near enough the same as BS 1192. You will also notice that if any of you have seen this maturity diagram, which has been around for a very, very long time, the wedge, it now looks a little bit like this. So if you ever see any BIM adoption programs nowadays, you will see this program on the right. There is no longer level 0, level 1, level 2, and level 3 BIM. You have stages of BIM. You will notice there's no stage 0 and there's nothing after stage 3. Okay, so I don't want to get into massive amounts of detail today, but stage 2 BIM is level 2 BIM. Not that much has changed apart from we now have these ISO standards rather than the PAS documents. Okay. Anyone that does get involved with projects and needs to know more about this standard, take a look on our website, because we're running a great session at the beginning of May over in Milton Keynes where we're really going through the end-to-end of the 19650 standard and the transition from PAS. Okay, so what about us as manufacturers? Fine, we now kind of understand why BIM exists and what BIM's all about and some of the challenges around BIM and actually why there is a use to the BIM model. But what does it actually mean for us as manufacturers? What do we need to do? Where do we need to get involved? And before we show some technology this morning, I kind of just want to focus on a few bits. So firstly, in the UK, there are some standards that if you want to be able to create BIM models, you need to be able to understand. Excuse me. The first of which is BS 8541. That's a series of documents with several parts to it. If you are creating BIM objects and BIM components for use, you need to get and understand that document because it's all about the naming and the creation of library components. That ties in hugely to the MBS level of development and the MBS BIM standards. So the MBS are a governing body in the UK, or not a governing body, a standardization body in the UK, who are really driving the adoption of BIM objects. They create BIM objects and they push the standardization of BIM objects. Alongside those, you have Uniclass Classification 2015, which is a common classification system. You have the ability to deliver against COBie, for example, 2.4 is the version that we use in the UK. We have IFC, which is ISO 16739. You might need to understand a little bit about the 1192 documents and a little bit about 19650, but not likely unless you're actually hands-on on a project. Typically, all of the object standards, so BS 8541, the MBS LOD, Uniclass 2015, COBie, ISO 16739, not necessarily the project-related standards. They're not going to be that useful for you as manufacturers. Now, I'm not going to go through the entirety of BS 8541 today because, quite frankly, we would probably all fall asleep and it's a little bit dull. But that is a document that you will need to understand fully if you want to push BIM objects. What we do need to talk about today is the importance of level of development or level of definition or level of detail historically. So every BIM object, every virtual component has a level of development. That's basically split into a level of detail, which is your model geometry, and a level of information, which is all of your properties, your parametrics, your information. Now, as manufacturers, we model as is, as built, one-to-one, everything perfect, nuts, bolts, washers, threads, everything that is needed to show that project to go and make it on the shop floor. From a BIM perspective, that is overkill. What we need to do is make sure that we have a representation of an object with a very high level of information. Again, for anyone that needs to understand about ISO 19650, level of development is changing to level of information need. In other words, we're trying to drive everything back to the client or the owner of the asset so that you have them defining exactly what they need. Anyone that is using that, please don't refer to it as loin because it's not meant to be a synonym. We've got too many of those inside of BIM. So we have level of information need. So let's get to it. Okay, we understand a little bit about the standards now. We understand that we need to have a detailed model that is a representative model alongside a load of information. But how do I get there? Well, we basically have what we call 5 steps. They're relatively straightforward, they're not too difficult, and actually the majority of you on the call are probably using Autodesk Inventor already, so your life becomes a lot easier because you know how to model. So step one, you model some geometry. So you create a 3D model. This might be reusing model geometry that you already have, more on that shortly, or this could be natively modeling something from scratch in a family editor inside of Revit. We then identify what it is by the different standards that we are needing to use in the UK. So we go onto the MBS website, and then we specify what entity that product has under MBS. For example, this particular unit that we have here is a 90-40-40-350. We're basically classifying it to the MBS object standards. The next step is to give it a uniclass code, a classification code. We commonly classify things on BIM objects to make sure that no matter what it looks like, we know exactly what it is. We should be able to have a load of models that are just made up of very simple representative components, but with a very detailed hierarchical classification code, we can tell whether it's a standard opening, we can tell if it's a wooden door set, a composite door set, a revolving door, or whatever it might be. We have a common classification system that is hierarchical to control that amount of data. We use the IFC standards to decide what it is within IFC and what properties it needs to have within an IFC, before finally adding any additional parameters that are asked of us from a level of information perspective. They basically sit on a spreadsheet. To give you an example of what that might look like, let's take a steel frame. So at LOD2, level of detail 2, that steel frame would be very visually representative. If you look at the plan on the right hand side, you can basically see that there is an indicative beam and column layout. They're not hugely detailed, there's no connections. It's a very simple representation of a steel frame. At level of detail 3, we then have a 3D model that's attached to that plan. It's a little bit more detailed, yes, but it's still far from being what we would see as detailed from a CAD model's perspective at manufacturers. It's there to provide a visual representation for confirming technical design stage and to be able to support spatial coordination. When you're at LOD3, you also have a number of properties, LOI, level of information, that you need to attach to that steel frame. That then builds. So at 4, you have sectional detail. You have 2D detail that's showing you about connections so that you've got something that is fully technically designed for full spatial coordination. And because of that, you have a load more properties attached to it. At LOD5, you're starting adding 3D information with regards to how these components are being constructed together. You might start to add information about how the columns are being connected into any slabs or any footings or whatever it might be. We have something that is ready to sit in an O&M or a handover manual. Because of that, LOI at 5 is much bigger. So you have a load more different parameters that you need to start adding. There is no LOD6, there is just lots more information to add. So the biggest detail model level we can get is LOD5, but at LOD6, we can get a load of additional properties, which is basically COBie, to define what that product is. So only additional information. What that looks like in a CAD model is this. So here is a very low level LOD. Maybe this might be LOD3. We have basic 3D representation of a model. That would then transition through the process to have some connectors. So we can now see that that steel structure now has some 3D modeled connecting points at the end of the beams and the columns. If we take an MEP design, we have some ductwork. Very basic design, very basic information that we have in 3D. As that transitions through, we get to the point where we might have flanges on those ducts. We might have hangers on those ducts so that we can see how they're positioned in a building. We basically go through and have different options for generating this information. Okay, we model top end, so we model as built as manufacturers. So we are far beyond what level of detail 5 is asking for. So in most cases, we actually have to strip what we have back so it's simpler. The good news is you've got a few options to get to the point where you're actually delivering models. And we're just going to talk about some of them now before we show you some of them live. So option number 1, and something that people try and push hugely in the UK is the use of an external library creation service. So people like the MBS, people like BIM Object, BIM Store, and all the others out there will offer to create BIM objects. We do the same thing. It's a relatively straightforward process creating BIM objects, but it's very structured and very standardized. And without having the time and effort required to understand the standards, it can be quite difficult to get, let's say, a compliant model, if there is such thing as a BIM compliant model. So a lot of people will go and use a third party to generate the objects for them with the detail levels and the information as defined. But actually what more and more manufacturers are starting to do is create their own. Because again, the process isn't difficult. The biggest part of it is really understanding the standards in detail so that they know what they need to do from a detail perspective, what they need to do from an information perspective, and what properties and naming conventions they need to follow. Essentially, you need to focus on reaching enough detail, not too high, not too low. Most people will aim for LOD4 as a maximum when they're creating BIM objects. We don't need to go higher than that. We simplify hugely. We shrink wrap inside of Inventor. We make sure that holes are covered and may be represented by 2D geometry only if they are vitally important to the design of that object. We will cover that shortly, live in technology. The next thing you can do is actually leverage what you've already got. So again, I'm guessing that the majority of people on the call as manufacturers will have some form of parametric CAD software. Now, we're an Autodesk house, so I'm going to be biased and say that Inventor is fantastic. It actually works really well with being able to leverage your manufacturing CAD data to drive your BIM component creation. Other manufacturing CAD software advertises that it can do such thing, but it advertises and pushes it through things like IFC. You should not be using IFC to drive a BIM object. The reason being is IFC is not designed to hold a family component. IFC is designed to hold an entire building, an entire structure of a building, an entire MEP design of a building. Revit won't let you place one component as an IFC. It will only let you link an entire design as an IFC. So you should not be using IFC as a building object. So we can actually leverage data from the likes of Inventor. And again, I'm going to show this live shortly. You do need to be cautious of detail levels. In other words, use the tools available to you inside of Inventor or SolidWorks or whatever it is to shrink wrap and cut back that design so that it meets your requirements at, let's say, LOD4. You've then got two options from an Inventor perspective. You can run through the BIM content exchange manually. The tools are very, very user-friendly. They work extremely well. And again, I will show you them this morning. We can also fully automate that process, which is something that that we've worked on very specifically with a number of different customers. And again, I will share that workflow with you this morning. There are other pieces of technology out there. You might have heard of GoBIM or CoBuilder, which also allow you to drive some BIM compliance because those pieces of technology do not focus on the creation of 3D. For example, the most important thing is the information. Any Revit modeler can model a Revit family. It's easy. It's very straightforward. But what they can't do is attach the manufacturer's breadth of information and know-how about that product to those objects. What CoBuilder allows a manufacturer to do is throw a load of properties onto a cloud-based solution where Revit users can literally download those straight into a representative model in 3D. Again, hugely, hugely beneficial. But you've got to make sure in one way, shape or form that the information about both the use of the product, the access areas around the product is intact and is sent with those particular components. So that's enough of me just talking about BIM for a second, and I want to show you some stuff. So I've got a few different things that I want to demo. We can't demo everything in a short webinar, so I'm just going to do a few tasters just to show you how you might draw manually inside of Revit, how you might manually use the BIM exchange in Inventor, and how you might completely automatically drive the BIM exchange within Inventor. So I've got 3 demos that I want to show you before we jump back into the PowerPoint to finish off. So I'll start off just natively inside of Revit. Again, we've not got time to drive and draw an entire family today, but I want to give you some confidence that the process is not that dissimilar to probably what you're using day to day. It's not that dissimilar to drawing a box in Inventor and adding some custom iProperties to that box in Inventor. So inside of Revit, we have a very capable modeling platform. I mean, it should be. It designs buildings, right? So we'd hope it would be very capable. So I can say to go and create a new family, go and grab a template dependent on what type of component I'm creating. They're all there for us ready to use. So if we're creating lights and we're a lighting manufacturer, we've got lighting-based templates to draw ceiling-based, wall-based, or floor-based lighting fixtures. If we're a mechanical equipment designer, for an example, an air conditioning unit, we have ceiling-based, wall-based, and floor-based templates to make our life much easier. For the purpose of today, I'm just going to create a generic model, because what we'd want to do from a BIM perspective is draw representative geometry and then add information against that. And again, just to give you an understanding of how this works, it's very similar really to drawing inside of any other piece of CAD software. We have a workspace. These are just center lines. Think of them like work planes inside of Inventor. Okay, they work exactly the same way. The only difference really that we do inside of Revit is we control some intelligence. So we have to create more of these work planes, probably more so than we do inside of the likes of Inventor, to actually start modeling. We follow a very specific modeling routine where we create the skeleton first, and then once we've got the skeleton, the body follows very easily. If we can get all of the intelligence working with the skeleton, we have something that will typically work extremely well. Now, there are a number of tools in here that work ridiculously well. Like I have 2 dimensions, I've created them at once, make them equal. I'd love to be able to do stuff like that inside of certain manufacturing pieces of software. But it works well. We go in and create some dimensions, and I'm just going to come in and say that I always want these 2 to be equal, and I always want these 2 to be equal. Let's say that I want this to be 3 meters by 3 meters eventually, and we'll just draw a very simple box. We'll go to the front view, and then we'll go and have exactly the same process on the front. So I'll just create another reference plane here on the front view, and I will control that reference plane with yet another dimension. All of these dimensions can be linked to parametrics, just like Inventor. So I can create a parameter called height, and I can link this dimension to it. In other words, that dimension has a parameter which I can go and look in and I can drive. So I can set a parameter 2.5 meters and it will parametrically update my model. Again, there is nothing new in there for probably 95% of people on the call. It's parametrics. It's what we do day to day in the likes of Inventor. I'm going to do the same thing here. So I'm going to say that I want a width, and I'm going to link that to this dimension, and I'm going to say that I want to have a depth, and I want to link that to this dimension. Just to make my life a little bit easier, I'm just going to round all of these up so that we've got 2000 by 2000 by 2000 millimeters. So at the moment, I've not created any geometry. I've just created a skeleton. But because that skeleton flexes and works parametrically the way that I want it to, I can now very simply come in and just say, well, let's create some geometry on there. We have all of the standard functions we have in Inventor. We've got an extrude, we've got a loft, we've got a revolve, we've got a sweep, we've got a swept blend, which is basically a loft following multiple access points. I'm going to create an extrusion. I'm going to draw a simple rectangle and then use an align tool to basically lock my geometry to that intelligent skeleton that I've just created. So rather than doing a simple sketch, locking it with constraints in a sketch and then extruding it, I'm creating work planes to drive a lot of intelligence. This is a very simple model, so it looks like overkill, but you can imagine when you've got windows, doors, an entire conservatory running parametrically, this process is going to be really key. What this means now is when I press the big green tick, I basically have a box. I'm just going to link that box to my height and lock it. Head over into a 3D view, turn on a slightly different view so I can see my box here, and show you that we've created a fully parametric box in a matter of seconds. So we can come in and drive any element on here, no issues. It's a parametric component. The key, if I wanted to start making that into a BIM object, is to make sure that you're matching the level of detail required against that object. So modeling is very straightforward. To attach detail, if it was just, let's say, a simple piece of furniture, so a very low LOD of a table or a desk, for example, I would come into my family types and literally, just like adding custom iProps in Inventor, I would come down and say, add a parameter, define what type of parameter that is, and give it a name. Let's say that I want to be compliant to COBie, so I need to put some COBie or some BS 1192 Part 4 information in here. So I need to have a type name, for example. That needs to be a type parameter, it needs to be a piece of text, and I want to group it under data. That literally creates a blank parameter. I can then go ahead and give it a name, such as, I'll just call it family_01. Doesn't really matter. I want to create another one, great, go and create a new parameter. I need to have a warranty, duration for labor. It needs to be, again, common, a piece of text, and put it under data. That then might have 3. You then have a warranty duration units and you put years in there. But these are the kind of properties that we add. Yes, there's a lot more to it. There's a lot of properties that we have to add, but that's the process you're going through. You're modeling something in 3D to a given LOD, level of detail, and then you're attaching information to it. Okay, some of that information might be hyperlinks, but the process is not difficult. The biggest part is understanding the processes and the standards involved. In other words, it's changing someone's thought process, the changing of people, and changing an organizational process to make sure that you're following it. Again, 2 of the most difficult things to change, but we have the ability to assist and help you with these. Let's just jump into Inventor now and just show you another couple of workflows in Inventor before we just open up for questions and finishing off at the end. First thing I want to show you is just a manual process. And again, just to drive how easy this is, I've just downloaded this component from GrabCAD. So it's just a third party, a nice little simple part model of a boiler. It is literally modeled in a single part, so it's nothing overly complicated for the purpose of today, but it's a very nice visual representation of a boiler, and we're going to imagine that that boiler is perfectly representative in this case. So what we'd want to do is start finding things that aren't really important from a BIM perspective and turning them off. So it might be that in this case I say go and find a feature, I go and grab that feature, and then in the feature tree I might say that I want to turn it off and start suppressing features to turn them off to control my visibility. Yes, it's very manual. Yes, I have the ability to use, can't find my suppress button, going a little bit blind. Suppress features, there we go. Yes, it's a bit manual. There are automated ways of doing this, which I'm going to show shortly. But typically speaking, we go in and we simplify the model. Whether you automate that with shrink wrap, with derived component, or whether you do it manually is completely up to you. The key is once we've got to a point where that component is simplified enough, in Inventor, probably for the last 3 years or so, we've been able to go to environments and go to our BIM content area. Now this is a boiler, so it's got a number of different connection points around here. So I can say, well, I've got a duct connector, and that duct connector is going to be circular, and I want that to be linking to an exhaust air. I can then go and click the diameter of this at the top, control how big I want that to be specifically. So I don't know how big this is modeled because I've literally just downloaded it from GrabCAD, but let's imagine this is 150 millimeters or something like that. Let's grab that diameter, make sure I put mm on the end, select the component, the joys of live demos, try that again, there we go. Choose the direction and press OK. We now have a connector on there. The significance of that is that Revit will understand that a duct can connect to that point. We can have duct connectors, we can have pipe connectors, we can have electrical connectors, power connectors, data connectors, so on and so forth. Hydronic supply, and this is all aligned to talk directly to Revit. So these set up, this would then work as an MEP component within a system inside of Revit. I can choose a UCS. If my UCS was not what I was expecting, I could come in and choose any base point for this and define where my X, Y, and Z positions are, should I really want to. And this can literally be anywhere. Whilst you would typically be very accurate, it's just the flexibility. I can click any point and then define any edge to be my X, Y, and Z should I want to. We would run through this process, use iProperties to attach all of our BIM information before authoring the BIM component to tell Inventor and Revit what that component was going to be. Based on what you select, this does use omniclass or uniclass, so there's a few things that you have to do to make sure that you are mapping correctly. You have a model property, and based on what you choose in omniclass here, it will allow you to go in and specify, that'll do, what component properties we do and don't need. I can then export that building component and save it directly as a native Revit family from Inventor. This will go and use whatever component geometry you've defined, and it will export it and bring it directly into Revit. What I have on the screen here is far too overly detailed for Revit, but it gives you an idea of what we can do. If I go into Revit now and just choose to go and open that family up from the desktop, you'll see that we've got a really nice representation of that exact same geometry inside of Revit. Okay. The materials have not come across very well, it's all white, but as you can see, the geometry is all there. It's my graphics card playing up, I think, more than anything else. Here's my MEP connectors. My MEP connectors are there, ready to be connected to a system. Which means, just to give you an idea, if I came into a project inside of Revit and said that I wanted to load this boiler that I have here into that project, an MEP designer using Revit could place that component and then draw ductwork from that component, or draw pipework from that component, or indeed connect that component to an existing system. So it becomes very simple to work with, very easy. Again, the biggest part of this is understanding what you need to do, what standards you need to follow, and what naming conventions. In some cases, it might be that you've got very, very common components, and those common components are very similar throughout their designs. So to give you this example here, this is an example of a customer that we did some work with that do a load of door canopies and similar objects which attach directly to a building. They were being asked for BIM components. This is, I guess, a typical or maybe one of more of their simplistic designs, but they've got a representation of what the building is here and then their model. We have ways using Inventor that we can completely automate the process you've just seen. I'm not going to go into the full detail today, but for example, I'm going to run one piece of iLogic. In this particular customer's instance, this was all automated directly through Autodesk Vault. They did not need to do any pressing of any buttons, change a workflow, and it does what they need to do. I run one rule. It's stripped out the wall. It's gone into BIM Exchange. It's shrink the component. It's changed the front of the view cube to match the front of the model. It's adding all of the properties in the background. It's adding all of the level of information. It's making sure the level of detail is matched. And this is now going to create an RFA file, an IFC file, and an ADSK file from Inventor. If we just give that a couple of seconds and I jump over into File Explorer, here's the RFA file, here's the ADSK file. Give it a couple more seconds and Inventor will pump the IFC file into there as well. And for those of you that didn't know, when Inventor creates an IFC file, it also creates a native RVT Revit project. Check your temp directory, you'll find a nice native RVT file in there should you need it. 3 files, very specifically named, can define a standard if you want it to. And those files are ready to be used again natively inside of Revit. Just to show you the process, let's go and open up those families inside of Revit. I'll go and grab just the native RFA file and open it up. Head over into a 3D view, change my detail level so I can see what's going on. You've got a match in material, all the information the customer needs. That file is now ready to be placed directly into a Revit model. That process of automation works really well if you've got a set product that changes in size and shape inside of Inventor. We can use iLogic, we can use Configurator, great. But then once it's set, it's set. We pump it out to BIM Exchange, you get a very good quality model, and you don't have to do anything. If you're using Vault, you can drive the whole thing automatically through Autodesk Vault, which for me, being a self-confessed geek, is really quite cool. Okay, I'm a bit conscious on time, so I just want to do a couple of next steps, really. So if you are still with me, thank you very much for your patience. And just a couple of points just to take away before I see if we've got any questions. So firstly, if you haven't already deciphered, we have a huge breadth of knowledge in the UK, and we've got a load of customers that we've worked with, from creation of simple BIM components to actually working live on a project, to transitioning from plain vanilla AutoCAD all the way to working in a BIM workflow. We also have full automation projects where we're looking at complete customization of iLogic scripts for customers. We're looking at how we can work with modular homes. We're looking at configurators for BIM-based components that drive Revit files from a configurator inside of Revit. So we have a load of experience with working with a number of manufacturers to develop BIM objects. So please come and talk to us if you need to, A, just understand what you need to do, or B, actually we don't want to understand the standards internally, please come and help us with it. By all means, we would love to come and talk to you, understand your pain points, understand your business, and give you a helping hand. The last slide that I just want to show up is just to reiterate this new course. If you have found any of the content today interesting and useful, a lot of it is from this BIM for product manufacturers course. So a very small example, let's say, of what this course looks like is what you've seen over the past 55 minutes. We have this course running in Birmingham on the 10th and 11th of July. It is filling up very fast, but if you are interested in learning about 3D BIM from a manufacturer's perspective, coordination processes from a manufacturer's perspective, and how to create those BIM models with relevant clearance around them, the processes around creating them, the QA processes, and the management of all of that, then please get in touch with your account manager, who would be more than happy to talk to you about that course where places are filling up fast. And really, that's kind of all I wanted to talk about today. I've overran a little bit. I was hoping to finish and open for questions at 1:15, but I always overran, so I'm not hugely surprised. So if you do have any questions at this point, please use the type in on the right hand side. I don't want to open up the phone lines to the amount of people that we have online, because it will become a little bit messy with a lot of feedback. So on your flyout on the right hand side, there is the ability to ask questions. I'm just seeing if we've got any. Can we have a copy of the slides? If it's up to me, absolutely yes, you can, but I would need to check with my peers just to make sure that that's okay. But I have recorded the entire session, which will be going live on YouTube later today. So if I can get the slides to you, absolutely. But either way, you'll be able to see the whole session again on YouTube. I have another question here from Alan. Good morning, Alan. As a manufacturer, we use SolidWorks, and one of the frustrations I'm facing is the fact that everything is geared towards Revit. We cannot export to Revit, and so I'm using IFC, which, according to the information I've read, is the best format to use, but I state otherwise. How are manufacturers that do not use it? Okay, so it's a very good question, Alan, to be honest with you. Again, you could use IFC, but it's not what Revit is expecting, or what ArchiCAD is expecting, or what Tekla is expecting. So to give you the example from earlier again, when you use an IFC in any BIM authoring tool, not just Revit, any BIM authoring tool, it's not expecting to find one component. What it's expecting to see is an entire design. So, for example, let's imagine that as a manufacturer, I make a flanged piece of ductwork, and I want to send that flanged piece of ductwork to a designer to place in their model. If I send them an IFC, they won't be able to say insert duct and use this IFC. They will only be able to link the IFC, which will be expecting to find the entire ducting design for the entire building, or at least a big area like a single floor. The IFC file is not designed to hold a single piece of information like a single component. Now, from SolidWorks, if you are a SolidWorks user, there is a workflow that does work from SolidWorks to Revit, and that's to use I can't think of the file format off the top of my head. It's not STL. It might be an OBJ. Basically, there's another file format that you can pull directly out of SolidWorks that Revit will allow you to bring into the family environment. It's a bit more manual, but then your products will actually be usable by Revit users, architect users in ArchiCAD, Tekla, so on and so forth. So IFC will work, but it's not what things are expecting inside an authoring tool, and that's not just a Revit thing. Unfortunately, that's just how IFC works. So probably a bigger discussion, Alan, that I could drop you an email on after the session. Hopefully that answers a bit for now. So a question for Alex. What's the limit of BIM model size, and what are the pros and cons for collecting a BIM model? Okay, so I would say there's no very strict size limit, although people will be looking for the smaller the better. The main thing is, as I said, it needs to match the detail level and it needs to match the information level. Dependent on the product, if you've got a very big product, like a prefabricated skid, for example, and that's got loads of pipe work, internal routing and things like that, it's going to be a fairly big file. The key is to make sure that things that are just not relevant in the Revit design or the ArchiCAD design, like perforations, holes, little fins, vents and things like that, just get rid of them. Any internal information, get rid of it, so it's just a dumb solid lump. That's what we'll be looking for, and by doing that it will limit the size of the component, which is great, but there's no real strict it must only be this big. The smaller the better, but I don't think there is a complete upper limit. David, you've got a question again. Good morning. Thanks for your time this morning. How do you link 2D section drawings and details to 3D models in Revit? So when you create an object, the only way to do this is to natively add that information inside of Revit. You can't take sectional information from the likes of Inventor or SolidWorks or anything else and pump that directly into Revit through the BIM Exchange, for example. If I was natively drawing in Revit, or if I was importing data from Inventor, once I'd then got that in, I'd open it up in Revit natively, and then I would use the 2D model lines functionality to add the 2D information either on a 3D face or in a 2D section. And then inside of Revit, you can control exactly what geometry is shown in what view. For example, only show this geometry in section because it's only sectional detail. Only show this geometry in 3D because it's only there to help visualize the 3D model. So it's a bit of a manual process, but that's the same for every single piece of BIM authoring tool. Again, very specific, but something that we cover very specifically when we teach Revit components. Tim's asked if there are any limitations with Revit LT. Architecturally, Revit LT is near enough identical to full Revit. Revit LT does not allow you to use third-party plugins. Revit LT does not allow you to work, share, and therefore collaborate effectively on a project. And Revit LT does not allow rendering or system design or structural design. So it's just an architectural tool. If you're a one-man band architect, it's great. If you want to use Revit LT to design families, it's great. But if you're working on larger projects, if you're MEP, you'll need full Revit. Hopefully that's asked your questions, Tim. David, can you just send a product data template, Excel spreadsheet? Oh, too many questions flooding in. I've lost that one. Can you just send a product data template, Excel spreadsheet to the customer to comply with BIM stage 2? So that's a difficult one, to be honest with you, David. Arguably, yes, because it's given them the information and you've given it in a shareable format, but they might be expecting a little bit more than that, I guess. If you want to drive down that data route, I would investigate CoBuilder and GoBIM, because that does exactly that in a very BIM way. So it's all connected directly in Revit, so that all the architect or the structural engineer or the MEP guy would have to do is press a button and it will pull your data into the model. So whilst arguably by providing a product data template in Excel, it's giving them everything they need, you've got to ask what's BIM stage 2 compliance. You know, there's no BIM police. Now that we've got an ISO, yes, there will eventually be audits on that BIM ISO, but it's very difficult to police and say what is level 2, what is stage 2, what's compliance. So arguably yes, but I think there's probably a little bit more to it that you have to follow there. We've pretty much run out of time, so I'm just going to pick one more that I haven't asked a question for. So Larry, manufacturer who designed ductwork systems, do we need to follow the naming convention and document control system using BIM 360 Docs or Vault? So Larry, it would depend on how you're getting involved. So if you're a fabricator and you get the MEP designs from a typical MEP designer, and then you are contracted to then design that properly, or so it can be fabricated and and manufactured, the likelihood is you'll be asked to get involved in the BIM process. So you should probably understand a little bit more about BIM. Again, Larry, it's probably worth a further discussion so that we can identify exactly where you're getting involved and what's going to be useful for you to appreciate and understand. So potentially, yes, it's certainly worth reading up on the standards from a project perspective, because you'll be excuse me, you'll be pushing more on a project perspective. If you're using fabrication tools, then they really are key to try and allow your products to be designed earlier on. It means you have less rework. But I think that's probably worth a further discussion at some point, so we could get in touch via email. Okay, I haven't answered all the questions, but if you have asked a question, I will get back to you by email if I've not answered it. I think I've answered pretty much 95%, but we are out of time this morning. So thank you very much for listening. Thank you very much for your attention and taking time out of your busy schedules. I do wish you a very pleasant weekend. The sun is still shining. The skies are still blue, and I think it's supposed to stay that way. So enjoy your weekends. Thanks for joining us, and we will have another one of these very soon. So look out for the mailers, and we will catch you next time. Have a good day. Cheers now.